That means the first derivative will be equal to 0 if you need to apply this concept. Okay, now let us go back to this word problem. The sector is given. I'm going to draw first up. Because it's the very first question. I'm going to go a little bit slower. The sector is given with all the measurements over there as well. Now, given the parameter of the sector is 7 cm. How to find the parameter? Yiting, remember you asked me this question before? How to find the parameter? Don't look at me innocently and act beautiful. Or I need some answer to come out from the mouth. Parameter is the whole green line over here. First thing, what is this called? It's the arc, or rather, if I want to find the length over here, this is the arc length AB. Am I right? What's the formula for finding the arc length AB? Given the radius is r and the angle subtended is theta. R theta. Okay, R theta will be the arc length over here. So how to find the parameter? This is a trick question. This is R theta. How to find the parameter of this whole? Yes, thank you. The parameter here is equal to R theta plus 2R, and this is given to be 7 cm. Now, they want you to show the area is given in the formula there. Okay, what is the area of this sector over here then? Viviana, what's the area of this sector? They want you to show, but I don't want that formula. I want the general formula first. That's the formula we learned last year. Isn't it? Or theta r? I don't know how Mr. Fung has taught you all. Is it theta r or r theta? Did she teach you all r theta or theta r? R theta. Okay, then r theta again? So I'm going to go through once and for all, but before on first. Area. You need help, you talk to a friend beside you. It's already stated as radian. I gave you all the question just now to read. It's not in degree. Hello, all this will not be given. You have to remember. Half r squared theta. This is the area. Okay, now the thing is, this area and the area given is different. Can someone tell me why different? What's the main difference? If you notice the one given in the question, everything is in terms of r. But we have it in terms of r as well as theta. Am I right? Now, the thing is, you must make use of what I call this the constraint. There is already a given value given to you. Your only thing that you need to do is make theta the subject, substitute inside here, and everything would be in terms of r. Okay? I'm going to do that now. Make theta the subject. So r theta is equal to 7 minus 2r. Theta will be 7 minus 2r divided by r. Okay? Now, because I already have my value of theta, I just have to substitute back into the area formula. So area, in this case, will be half r squared, 7 minus 2r over r. Now, can I reduce to lowest term? Yes, I can. R squared and R. And it looks exactly like the one given in the question. And you are told to show this. We have shown. Okay, this is only the first part in showing the area of the sector. I'll show you the formula later after I finish all the questions here. Alright, so bear with me for a short while. Hence or otherwise. Whenever there's the word hence, remember, use the previous answer. Unless you have other method, then you use the otherwise method. Show the maximum area of this sector. Remember, we go back to all these key English vocab. Finding the maximum area, it also means that you want to find the stationary value. The stationary value for this area. I'm going to write out first. If I want to find the stationary value for this particular equation, you would need to differentiate A with respect to R. Agree? Previously, it's always Y in terms of X. Alright? That's why we have dy over dx. But this equation is A in terms of R. So we need to have dA over dr. But do we want to do our differentiation immediately? Kevin, why no? Then how can we make it easy? Please multiply inside term by term. Don't differentiate and use product rule. Okay? Word problem, the differentiation is easier. You just need to simplify first. So I'm going to simplify now. So this is my equation for A. Now, applying. I'm going to write this out the first couple of times, but until you are very familiar, then I will write this for maximum value. Okay? Because we want to find maximum value, your dA, dr. Differentiate A with respect to R very quickly. It's very straightforward. 7 over 2R. No, sorry. There's no more R. Minus 2R must be equal to 0. Agree? Because of this concept, the first derivative must be equated to 0 for you to find maximum value. Or in other words, not really maximum value, stationary value. Okay, all this did not be in the working, but I'm just writing down first. Now, solve for R. So it tells you when R is equal to 7, you will have a stationary value. Yes, Kimberly? Oh, exam over 4, thank you. So in this case, it will be 3 and 3/4. Okay, it's in terms of cm. So this is the radius. This particular radius will give us stationary value. But have we proved that it will be a maximum area? No. Okay, remember the first derivative test, I'm going to write out again. Okay, the first derivative test will only allow us to find stationary value. But you want to prove that it's a maximum value. What must we do? We just said that at the start of the lesson. You want to prove whether it's maximum or minimum, you make use of the second derivative test. Now take a look. The first derivative is this answer. Is it very easy to do the second derivative? So Sophie, how to do the second derivative? D square A over dr square. If you differentiate this first derivative, what's the answer for second derivative? Negative 2. You don't even have to substitute. Negative 2, is it positive or negative? Negative. So we write less than 0. Agree? If this is less than 0, do we have maximum or minimum? Maximum. So imply maximum A. Okay? It's always maximum A, the one at the numerator. Okay? I highlight in red, but we are not done yet. Why aren't we done? They want you to find the maximum area. They did not ask you to prove that when R is equal to 1 3/4, you have maximum area. So now, there is one more additional step. Maximum area. Please substitute this R into the area formula, which is over here. So you have half, 1 3/4, multiplied by 7, minus 2 times 1 3/4, and please punch in the calculator now. Kenny, what's the answer? Three. Okay, it tells you for this particular shape that you are given, if the parameter is going to be 7 cm, the maximum area that you can obtain is 3.5 square centimeter. Okay?